Hello everyone, this is lecture number 5 of the topic of variable mass system, and today also we will discuss one problem of variable mass where a chain will be released from the vertical position and it will be continuously falling on the ground. Let's see what is the problem. Chain of mass m hangs vertically touching the ground by its lower end. So lower end of the chain is touching the ground. Find the normal reaction exerted by the ground when half of its length fallen on the ground. So I have drawn one picture here which is showing the half of the length that is already fallen on the ground and other half is just continuing to fall on the ground. So when half of the length is already fallen on the ground, that we consider a system. We will consider this as a system, and this middle point of the chain that time will just be injecting the mass into this system. So what will be the velocity of the middle point when the half of the length already fallen on the ground? So this each part of the chain will fall on the ground with different velocity. Let's say top part or the top point of the chain, when it will fall on the ground, the distance from the ground it is having L. So the height from the ground it is L. So when this top part will be falling on the ground, that time the velocity of that point will be root over of 2gh, so it will be root over of 2gl. So when the middle point will be falling on the ground, that time the velocity of this will be root over of 2g into height it had from the ground. So what was the height it had initially from the ground? That is L by 2. So we will write L by 2. That is the V middle point. V middle point. So it is root over of G into L. V mid. We will write it down like that. So that mass will be contributed in the system which has already fallen on the ground. So the part which has already fallen on the ground, what is the weight of it? Half of the mass is already on the ground. So mg by 2 will be the weight of the mass which has already fallen on the ground, or the pile up weight, mg by 2. But the normal reaction will not be equal to mg by 2. Why? Because it is a variable mass system. How it is a variable mass system? Each and every time this system will have continuous injection of the mass with different velocities. So at this instant when half of the chain already fallen on the ground, that time the velocity of this part of the chain is root over of gl. So with this velocity the mass of the chain will be injected in the system. So there will be a thrust force generated. So what is the value of the thrust force? We have already discussed in the lecture. dm dt, the rate of the mass falling on the ground, into the velocity of the mass falling on the ground, or the relative velocity with respect to the system which is already on the floor. What is the velocity of the mass injection? This is Vr. In this case it is root over of G into L. So dm by dt will write root over of G into L. Now what is the mass per unit length for this chain? Mass per unit length we will call it lambda, that is m by L. Now what is the dm dt? At what rate the mass is getting injected into the system? That is mass per unit length into the velocity of the chain at that point. Now let's see how dm dt is coming as lambda into v. So this is a concept of continuous system. Suppose one chain which is moving with velocity v, it is going inside a system. Velocity v, it is going inside a system. And what is the concept of velocity? So unit time, how much length will be going inside the system? V only. V is the length of the system that will be going inside per unit time. That is the idea of velocity. What is the mass of the chain which has already gone into the system per unit time? V into the per unit length. What is the mass? Lambda. So unit length mass is lambda. So V length mass is V into lambda. So that is the per second or per unit time, that is the mass injection rate, or that we call dm dt. That is lambda into v. That's how dm dt equal to lambda into v is coming. Now what is the velocity of the chain? You already know it, that is root over of G into L. The thrust force that will be generated due to the chain falling on the ground is dm dt into root over of G into L. So we got the value of dm dt, that is lambda into root over GL into root over GL. So it is lambda into G into L. And you already know that value of lambda is m by L. So we'll put that value m by L into G into L. So it is mg. See, the thrust force, that is mg. The already fallen on the ground part having weight is mg by 2. So total, if we consider this as system, thrust force is in this direction, that is mg. The weight of it is already there on the ground, that is mg by 2. So it will have normal reaction from the ground, n. So what is the value of the n? N is thrust force plus mg by 2. So that is 3 mg by 2. That is the value of the normal reaction. See, this value of the normal reaction is not the weight, but due to the thrust force also this normal reaction is getting contributed from. I hope you understood this problem.